Okay, now on this problem, I'm going to go ahead and try the same thing. I need everything on the left side. So it doesn't matter that that's an x over there. I'm just going to add 5x. So by adding 5x to both sides, oops, typed it in the wrong place. And then if I add 5x to minus 5x, that cancels out and gives me a 0. So once the right side is equal to 0, I'm ready to solve. You might want to try factoring that one, but with the 3 in front, it's a little harder to factor. And it turns out this one actually will not factor. Since it will not factor, it's not a great sign that Desmos is going to be super helpful, but we're going to try anyway. I have a 3x squared plus 5x, and I think that was a plus 1. And what I can see is I do have some x-intercepts of negative 2.32 and negative 1.43, but those x-intercepts aren't very pretty. It makes me think that those are probably just rounded off decimals. I may remember that there's a chance that I can write those decimals as a fraction. But if I can write those decimals as a fraction, remember we talked about last week how I can take that 3 in front and those I could basically multiply by a factor of 3 to turn it into a fraction, because any fraction that is a solution will have to have a factor of 3 as its denominator. Well, multiplying by 1 won't change a thing, but I could try multiplying one of those by 3. So I could take that, whatever what that was, negative 2.32, and multiply it by 3. And you notice that comes nowhere close to getting rid of that decimal. So that lets me know that that won't be helpful. So this is literally the type of problem the quadratic formula is made for. It's a problem that I could not factor. I couldn't find the exact solution by graphing, and maybe an approximate solution just wasn't good enough. If an approximate solution was good enough, I've graphed it. I could say my approximate solutions are negative 1.4 and negative 0.2 and move on with my life. But if I need an exact solution, it's time to pull out the quadratic formula. So here we go. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b would be 5, so negative 5 plus or minus the square root of, b squared, so 5 squared, minus 4 times a would be 3, c would be 1. All of it should be over 2a. Now, when I go to simplify the quadratic formula, simplify it, what's inside the square root? So I'm going to do 5 squared minus 4 times 3 times 1. I am not going to type that square root into Desmos or worry about it at all when I go to simplify. My first step is to simplify what's inside the square root. So once again, if I'm pulling this in Desmos, I have a 5 squared, and I could have that 5 in parentheses, but I don't think I would have to, minus 4a. I'm just going to leave the parentheses. C, you could change it to multiply, and I can see I get a 13. So what that means is everything inside my square root, this whole mess right here inside the square root, simplifies to be 13. So I'm going to now have a negative 5 plus or minus square root of 13 over 6. Now, if I look at the square root of 13, I could say, can I break it down any further? In this case, you can't. There's nothing that divides into 13. It's prime, so I definitely can't break that down. If I want to check and see if that answer is correct, I can go over to Desmos, and I can say, okay, what happens if I have negative 5 plus, and I can get the square root in the corner under my function button. I can't get to that. So I can do that, 13, and then I've got to put it all over 6. So I'm going to do a parenthesis and divide, and I can put it all over 6. I can see that this is one of my solutions. So one of my solutions is 0.23. And if you're like, well, what about the other solution? Well, the other solution is if I would have had the minus. So I have one solution, one decimal with the plus, the other decimal with the minus. I know that I've done it correctly by checking it by graphing. That's one reason I encourage you to always graph. It lets you know what to expect.